Welcome back to our class. We still looking at how to write zero knowledge proofs in Noir using Noir. We had last time we had installed Noir, and so today we're supposed to begin writing our projects using Noir. So that is our topic today. So I'm hoping you've installed it. If you've not installed, that means you go back to our last video, you check on how we were installing. Now, so there are two ways of installing Noir. Way. We shall proceed with the one we installed, but after some time, we'll again install another one. After some time, we'll again install another one and use it. So there are two ways of installing it. So the one we used was we installed via cargo. So we used the command cargo install nago. No, after installing Noir, you need to install nago. That's what I intended to say. After installing Noir, you install nago. So there are two ways of installing nago, and we used one. One way was the use of cargo, and we did do cargo install nago. So after we have used this, we shall use this one today. We shall use the one we installed today. And then in our next lesson, we'll now again install Nago. We'll uninstall this one and install another one, the most current, and that one is done via Noir wrap. Noir wrap. Let me just write it here so that you can see what I'm talking about. Let me see what I'm sharing. So the one I'm saying is that we install through cargo. Just a minute. Install Noir through cargo. And today we'll install, no, not today. After that, we shall install through Noir wrap. So this is the most current one, the most latest Nago. Now, you see, for you to write your project using Noir, you need to install Noir. First of all, we install Rust. Then after installing Rust, you install Noir. Then after installing Noir, you install Nago. So it's Nago that I'm saying that there are two ways of installing it. The one we used last time was a cargo install. And what the one we'll be using after that, we'll be looking at Noir app. Now, so how did we install Noir? Let me just again, as a recap, we were using our WSL. So you're either using WSL or you're using command prompt, whichever you pick, one of the two, or you can even use PowerShell. But a command prompt or a CMD is, or WSL, the mostly recommended, but you can use any of those three. Now, let me now, what we install, we used WSL. So before you install it, you wanted to know which directory do you want to install in. So you go to your terminal and type cd. For instance, for me, I wanted to install it in Rust programs. So in my terminal, I write cd Rust programs, enter. Then after that, I clone it using git clone https. There's github.com/nor lang. So that command, you can find it from our last video. So you clone it. Now, once it's cloned, you now cd nor, want to get inside and you get inside that nor that you just cloned. So you cd nor. Then after that, you say cargo build -- release. Now, so nor is installed. Nor is either I think it's pronounced as Noah. I don't know. I think that is how it's pronounced. Now, after you've installed Noah, you now want to install Nago. And to install Nago, you can use the command cd rust programs. You are still maybe inside there. And then cd Noah, and then cd tooling Nago _ CLI. And then cargo build release, then cargo install path. Those are the commands we used last time. You want to verify the version that you just installed, you can say Nago version in the command line, and that gives you the version. So that, of course, that again verifies whether Nago has been installed properly. So if it's not installed properly, then there's no version that we get. Now, so that is what we did last time. That's what we did. Now, we want to, this time, after doing that, we wrote a project, some projects. So I think I'll begin from there. Where we writing a project. We had already done that last time. But just for purposes of continuity, because today I want us to look at how do we write projects using Noah. And so that is where I'll start from. So let me just open my WSL. Just a minute. So I'll open my WSL, then share, so that from there we now proceed. So that means I'll share what I'm sharing and then share my WSL, so that from there we can follow up what we are doing. So this is my WSL. You can see my terminal. Now, so what I want to create a project. I'll cd Rust programs. That is where I want my projects to be. So that's what I'll do. I write in the terminal cd Rust programs. cd Rust programs, and then that is now, I'm now there. Once I'm there, I want to create what is the title of my project? What is the title of my project? I want to call it, just give it a name, and just give it a name. But in the command line, I have to write Nago new, and then the name of my project. Let me call it our project because we are doing it, you and I. So let me call it our project. So in the command line, I want to say Nago, so not cargo, it's Nago new, our project. That's the title of our project, Nago new. Now, so project successfully created. It's located at home, Cyprian, Rust programs, our Noir project. Now, so this is the name of our, this is where we are. I'd said we had opened the directory where we're supposed to store our projects, and I call it Rust programs. This is where we created it. At this point, we're creating our directory where we have to store our projects. Now, so therefore, to create a project, we just said Nago new. Then the title of our project, our Noir project. Then enter. Now, so once you've done that, you've created your project, and you can see it says that the project has been created and is successfully located at. So it's telling us where it's located, and there's no problem for that. We want to go to where the program, where it is. We want to go where it is and then continue writing our circuit. Now, so to go where it is, we CD it. We CD first, we enter that, project, our project, want to get inside. And then once you get inside, we'll now proceed with writing the circuit. So that's what I want to do. I just say CD, our project, then enter. So you can see at the bottom here, we have Rust programs. We are inside Rust programs. Then now we are inside our project. Now, so those are the steps. Those are the steps. So I just want to take you through these steps one by one until we write a circuit, and then close that. Then maybe write another circuit again, so that you can follow the steps. But what I'm doing everything inside my WSL. So if you are doing it inside your command prompt, you can, I'm saying you can also do it inside your command prompt, and these are the steps you would still be using. We are just still inside there, but we are about to get out. We are about to get out and go to our visual code. Then once we are in the visual code, we now write the program. So that is what I want to do. For me to get out, while here I'll write code, then space, dot. Code, then space, dot. And then it will open for me the visual code directly. It will open for me the visual code automatically. So from my end, I can see the visual code has been opened. So let me now share the visual code that is now open. I'm now out of WSL because that command gave me the visual code. And now the visual code, it opens the visual code automatically. You don't need to open the visual code by yourself. Once you say, and you can see what I'm sharing. This is the visual code is now open. Once you say code, then space, then dot, it opens. Let's just check what is here. You can see the title here, our Noir project. That's the title. You can see where I'm pointing. Then under it, you can see SRC. SRC. Inside, you can see main. And what is in main is this code. So this is just to begin from. You can delete this and insert the code that you want to be here. You can delete this and replace it by your code. But you can also see there's something else here. There's Nago Toml, and let's click there. You can see what is here. You can see the name of our project, and then the type, then the author's name. You can include it here if you want inside this quotation marks. Then you have dependencies if they're there, but if going forward, you'll see the dependencies here. As we progress writing our code, you will see dependencies. They'll just automatically appear here. But currently, they are not here. Now, so this is what we have. Let's just look at the code that has been generated for us automatically and understand it. Function main. X is a member of a field. And we discussed this last time, and we said it means that this X value is private because it has not been indicated as public. But if you wanted to be public, you would have written here pub. If you wanted to be public. But since it's not here, let's just maintain the way it is. It's private. Now, what about Y? Y is public. And you can see is also a member of a field. Now, this code does not have output. This code does not have output. What the code is just doing is that it's telling us that X is not equal to Y. That is the assertion. The assertion here is that X is not equal to Y. So when X is not equal to Y, this code will run. This code will run successfully, but if X is equal to 1, if X is equals to Y, the code will not run. There will be errors. Now, so there's a test. This one is just to test the main function. Now, the main function says that X should not be equal to Y. And that's what it's, for instance, the main function says X can be 1 and Y can be 2. In that case, X is not equal to Y, and therefore the code will run successfully. But if I uncomment, I've just it's written here, uncomment to make the test fail. So if I uncomment this, and you can see X and Y are equal, 1, 1. So that means in that case, the code will not run. The code will not, it will have errors because the main function has the assertion. The assertion is that X should not be equal to Y. Now, so that is how you have seen how we've gone up to the visual code. We began from the WSL and we ended up in the visual code. And now, so how do you run this? How do you run this? Now, so if you're on the visual code, you can run this by Nago. Is it? I think Nago test. Yeah, to give you some results. Let me just run it. Just run it. I'm the visual code. Let me look for the terminal. Look for the terminal. The terminal is here. So if you write here, Nago test, the terminal, and then press enter, there's some output. It says running one test function. Of course, there's only one test here. And then testing the main. The main has been tested and is okay. So one test has been passed. One test is passed. So there was only one test here. Now, so what it's saying is that 1 is not equal to 2, because that is what the main function says. The assertion in the main function says that x should not be equal to y. X should not be equal to y. So if you're giving it 1 and 2, where 1 is x value and 2 is a y value, then that is correct. Now, but when you uncomment this, so this is the main, and you want to run a Nago test. Want to run Nago test. Want to run Nago test. It tells you that the one test failed. One test failed. Let's just go where it began from. Where it began from. So this is where I wrote Nago test. Test main fail. Fail to solve the program. Cannot satisfy the constraint. Cannot satisfy the constraint. What was it? The constraint was that x should not be equal to y. So this cannot satisfy that. So if I change this to be 7, for instance, then it will satisfy, because at this point, x is not equal to y now. Let me just again run this. Oh, I used cargo run. That's not correct. I'm supposed to use Nago test. I'm used to cargo run when I'm doing Rust. And that is why when you're using Rust, you use cargo run, cargo build, but this one is Nago test. Nago tests. Now, so it says running one test, testing the main function, and therefore the test has been passed. The test has been passed. You can add as many as possible. You can even add another one here and try to see whether x equals to y. You can add another one here. Let me say this time 7 and 9, and see whether they are equal or not. Now go test. And again, that test has been passed. So this is a very simple code. And what it's doing is that it is trying to check whether two values are equal, are not equal. Checking whether two values are not equal. That's what it's doing. Good. Now, so that's what you would, that's what we would do. Now, supposing I wanted to write another circuit, there are two ways I can proceed doing this. There are two ways I can proceed. The first way is I can delete what I have here and replace it by another circuit, another program. So I can delete that and replace it by what I want. Now, if I don't want that, if I want to keep this, I want to keep this program and create another program. So you see, sometimes you want to keep your program, have a different program and so on, so that you have several programs, all of them kept well. And that is why we opened a place to a place where we can the directory for keeping this program. So I opened this directory so that all my programs are kept there, so that I do not want to delete any of them and replace by another. So if that is the case, so my directory is now, if that is the case, you have to go back to your WSL. You have to go back to your WSL and create another program. So that is what I want to do. I want to create another program. So I go back to, let me just again open, I had closed my WSL. So I open it and then I share, so that now we want to create another program. We want to create another, we don't want to delete the one that we've just written. We want to have all of them. So let me share again my WSL. This is my WSL. We would repeat the same process as earlier. Just the same process. There's nothing new. We CD, Rust programs. That is why we want to keep our programs. So we are there. And then after that, after we are there, we want to create a new program. We want to create a new program. And I want it to be called summation. I want it to be called summation. Because I want to use it for addition. I want to add. So let me call it summation. So it's the same thing. So while at the terminal, you want to say cargo new, and then give it the name of the program that you want to create, cargo new summation project. Then you want to enter inside here the summation project. So you CD it, CD summation project. You're there. Once there, you want to open the visual code. You want to go to the visual code and type your code. So as we did earlier, we are doing code, then space dot, code, then space dot. You can see what I'm referring to. That's what I'm sharing. Then when you enter, it opens the visual code automatically. So let me now share the visual code that I'm seeing on from my end. The visual code from my end. This is what I see from my end. This is the visual code. If you click the SRC and main, it's still the same thing we had earlier, the same code we had earlier. This time we don't require it. We want to replace by our code. And again, when you check on the left side, you can see the topic has changed. The topic now is summation project in WSL Ubuntu. Now the Nago Tomil is still that way. The name of the project has changed to summation project. Now, so we now want just to change what is in our main. We want to change that with the code we want. So we want to do some addition of two functions, not two x and y, two elements of the field x and y. That's what we want to add. So I'll just change this code by the one I want to write. And this is the code I want to write. Now, so my main.nr now is this. X is a field and is private. We said that once it's not indicated as public, is private. And this time, my y is also private. But I said whenever you have an output, in our previous code, we did not have an output. This time we have an output. And whenever an output is there, it must always be public. The output must always be public. You can see I've indicated public. We shall see what happens if I was to remove the word public. Now, so x plus y is the output. So x is private, y is private, and then x plus y is public. So I'll now test. And so my function, I want to test the main function. And I want to test if when x is 3 and when y is 5. So these two are private. What I'm giving the verifier is 8. Giving the verifier 8 is public. This one is public. The verifier has to know it. But the private values, the verifier will not get to know what they are. The prover claims to know what x plus y is. So, but it does not want you to know what x is and what y is. Every time you ask him to prove, it gives you a different value of yx, a different value of y, then gives you the summation. So that is what the prover will be doing. So let's do our Nago test and see whether it's correct. Nago test. Yeah, it says running one test function, testing test main is okay, and the test is passed. That means if x is 5 and y is, no, if x is 3 and y is 5, it's true that their sum is 8. It's true that their sum is 8. So if I were to change this sum, this test will not pass. Let me see, Nago test. Test will not pass because, yes, the test has failed. Now, but if I change this 5 to 6 and maintain the same sum, this test is supposed to pass. Nago test. It has passed. It has passed. Now, so I said that the field is supposed to be, the output is supposed to be public always. Let's see what happens if I was to remove a pub. And if I remove pub, it means I'm now dealing with a private output. Let's see what happens. Nago test, will it still run? And it has written something here. It has not run. It has given us something. Let's just begin from the start. I said Nago test. It says missing pub keyword on return type of the function. So that means it's supposed to have pub, which means public, on the return type where we have the output. it continues saying, the next line says, the function x, y, and then the output, there is a missing pub on the return type, where the return type is the field. The return type is the output field. Then there's something here, it says the pub keyword is mandatory for entry for the entry point function return type, because the verifier cannot retrieve private witness. You see, and the verifier cannot retrieve a private witness, and thus the function will not be able to return a private value. Not be able to return a private value. So that means every time the public, whenever there is a return, whenever there is an output, that output field must be public for the verifier to see it. I've now included a pub. Let me now again run Nago test, and it has accepted. It has accepted. Now, so what is the meaning of this? What is the meaning of this code? Let me just again look at the code. Okay, X, Y. We've already said that X in this case is private and Y in this case is private. If you want, again, you can make them public. Let's see what happens. You can make them public. You can make one of them public. Let me see. Nago test. It has returned. It is okay, it's correct. Let's make both of them a public, X and Y public. It's no problem. And say Nago test. And again, it accepts. So for the inputs, X and Y, they can be both private, they can be both public, or one of them could be public, another one private. But when it comes to the output field, it must be public. In our first code, there was no output because we were just testing whether that X is not equal to Y. X is not equal to Y. There was no output. So in that case, we didn't require the output to be public because it was not there. The output was not there. But where there is an output, it must be public. Now, so far, I've taken you through the process of creating a directory in your WSL or in your command prompt, and then creating your code inside that directory. We created the first one and then created the second one. We wanted all of them maintained, all of them kept in that directory without deleting any of them, because maybe we want in different instances. Now, so again, very fast, I'll take you through a process. I'll again create another code, the last one. And then we'll look at another subtopic. Maybe I just want to create another code. So let me just share my WSL. I had not closed it. Now, so I do not want the name of, just a minute. I do not want the name I don't know whether you can see or whether this thing is blocking you. Okay, it's now okay. Now you can see my terminal. My terminal has, I'm inside the Rust programs and then inside summation project, but I want to create another project that is not summation. So I have to get out of this. So cd dot dot, get out of that. But I want my name, the name of the program to be inside here. So it's Nago new. Then the name of project. Let me call it another project. Put another project. And then enter. Measurement. Project successfully created. It's located at that. Okay. Another project has been created. Let's get inside. So we do cd, another project. cd, another project. Measurement, cd, another project. Last programs. Adjustment, cd, another project. So I'm inside that. Now, once you're inside, you need to just write code, then space, and then dot, and it opens for you Visual Code. Let me now share the Visual Code that it has just opened. It is here. Now I'm going through all these processes so that you understand how you will be creating a project in Noir or in Noir whenever you require projects. Those are the steps of opening a project and then writing your project. So of course you're writing it maybe using Visual Code, or you may want to use another means, but I've explained using Visual Code. Now, once you do that, this is what you get. You just delete it and replace it by the code you want. So this is my new code. Just write it properly. It's just okay the way it is. Now, so I've called it another project. And this is the project. What is it doing? Now, this project, I'll tell you what it's doing, but before that, let's look at, of course, when you look at this, you can see that you have some public, A is public, it's not private. B is private, C is private. And then as we said, the outcome is always public. Now it's saying there's the prover claims to know the sum, which is a summation of B and C, and then claims that this sum is A. This sum is A. So A is the sum. So this person is doing A is equals to A plus B. No, A is equals to B plus C. A is equals to B plus C. So A is the sum. Now, so what do you want to test? Function test the main, you want to test this main function. You want to test whether what the prover gives us A and what the prover gives us B and C, whether B plus C will give you A. That's what we want to test. Now, so let the result of the main be, this is 7, 3, 4, where 7 is A and 3 is B, and this one is C, and as such, the result be 7. As such, the result is equals to 7. So let's just run and see whether it's true. Whether it's true that if 7 is A and 3 is B and 4 is C, whether it's true that A will be equal to B plus C. Now go test. And it's true that that main function is true. We tested and it's correct. Now, but what about if you give wrong values? I uncomment this. Now this time B is 2 and 4 is C. Is it true that B plus C would give us this A? So let us run. No, it's Nago. It's a Nago test. Now it fails. That one is not true. It's not true. So, but if you try to change, if you change this 4 to be 5 and do just changing so that you know that anytime you give wrong information, a wrong witness, then it's not correct. It will not run because the witness is wrong. Now go test. This one has accepted. Now, so you must have the part for test. Must have the part for test if you want to test your main function. If you want to test your main function, there must be this bit for test. If you remove it, the code will still run, but you'll not be testing anything. You will not be testing anything. But this time we want to test, so we include it. Okay, so let me just share the notes that I had prepared for today. They explain what I've just done, what I've been doing. I share those notes so that we formally, because you're writing this, you can have formal notes. Now, so these are my notes for today. So the topic is editing your Noir project. And I said once your Noir project is created, and I've taken you through the steps of creating a Noir project. So I've said once your Noir project is created, the next step is to define your circuit logic, and I've shown you those steps. Now, so Noir would use .nr file format with the code organized in Rust-like syntax, and you've seen that. So all logic is typically written in the SR main. You've seen it's main.nrs and .nr So you've seen what we've been doing. This is just a summary of what we've done. So you will specify public and private inputs and define the constraints as we did. Then Noir separates circuits logic from proving and verification. So it's never at the same point, they're separated. So what we did, we wanted to create our project. We opened WSL terminal. And I said you can also use the CMD, or you may want to use command prompt. This one is just typing at the start on your computer, where they start, you just write command prompt and you click on it, it opens. Now, but we went through the same process last time. So again, this is just a repetition of what we did last time, just to ensure that the point is home. Now, after successfully creating the Noir project, as we did, our project, we had stored it in Rust programs. So Noir project. So you would CD, you can just copy the whole of this and enter in your terminal, your WSL, and paste it there and then enter. Or alternatively, you can just CD Rust programs and then enter, then CD again my Noir project, and then again enter. So alternatively, you can do that. Once you've done that, what we did next was, you want to open the project in the Visual Code. You do it by writing in your terminal code space then a dot. You do that, code space then dot, then enter. So this automatically launches your Visual Code. And then that Visual Code will now have the name of your project. Just before I forget, now let me just unshare this. Supposing you wrote these projects earlier and you forgot how you named them, you forgot the name of your projects. Let's just go back to our Visual WSL. Let's go back to our WSL. Suppose you forgot the name of the project. Okay, let me just get out of another project. Now, I know that my projects are inside the Rust. How I stored them there earlier, so I've forgotten the names. I want the exact name. So I would just ask, I will just write is as ls, small ls, then enter. So when you enter, you can see all your codes, all your projects, like we had summation project. The other one we had was our Noir project. These are the ones we did with you, but the other ones I had done them earlier. The last one we've done was, we had done summation projects. We had the one we did together. The other one was our project. I think we did these two with you. These are the only two together. But you can see I have others. I have other projects I had done earlier. So by just writing ls, you're able to know, oh, there was another one. There was another project. There's another project. It's here. Another project. We did another project together. We did the summation project together, and then we did our Noir project together. So by just writing ls, then enter, you see all the projects you've ever done, because they are stored under this Rust programs. Now, what about if I was to come out of the Rust and then again write the same thing? Now, this one is now telling me whatever is installed in my WSL, whatever I've installed there. So it's telling me anything that I ever installed inside here. It's telling me whatever, there's Nago here, there's Noir, we have Rust programs, whatever is inside this WSL is telling me we have BB temp, we have BB older, we have, this one is used for front end. If you want to, for example, if you want to verify and prove, if you have written your zero knowledge proof and you want to prove that proof, or you want to verify the proof, then you need to install this. So you can see if you just wrote it ls here, then it's supposed to give you whatever is in your WSL. But what I wanted was, you are inside your Rust programs and you've forgotten the exact names you used. So you can now copy your name from here. You can copy your name from here. First of all, you may want to, okay, you want to open that file, that project. You want to open it again, and maybe you want to modify or add a few things here and there, or you are creating it and you never completed, you want to complete. So you've now seen what the name is. You want to CD Rust programs, go to Rust programs. Then let me say, for example, the name of the program you want to edit is addition, multiplication. Now you copy that name and CD that addition multiplication project. Now you are now inside that project. You can again open it by code space dot, and then it opens in the Visual Code. It opens in the Visual Code when you do that. So that is how you can open your existing project that you had already stored. Remember, this thing is not stored on your desktop. It's not stored on your desktop, but it's stored inside this WSL. So if I was just to share this, what I now see after that process, if I was just to open, you can see what I've opened. The name is addition multiplication project. You can see my main.nr. You can see we have the other things. You can even see nagotomil. You can even see the provatomil. You can see, but all these we shall look at them. How do they come here? We shall see how they come here as we progress. As we progress, we shall see how do they come here, because we're not typing this, They're coming here by themselves on some commands. They come here by themselves. So that is the only thing I wanted to, that before I forget, I mention, so that you may be wondering, after I've created this program, where is it stored? Or how do I get it? It will not be stored on your desktop or somewhere you can easily see. It is inside this WSL. So if you want to see it, then you just write on the terminal, you write ls, then you can see your program, the name of your program. You can now open that program again using the steps I've just shown. Now, so I had already mentioned this point, is that if you're using cell, stick to it. If, oh, this is not the point. The point is when you open the Visual Code this way, it will detect that you're using WSL. And you saw it every time we open the Visual Code that way, it wrote the WSL. So that is what we saw, WSL Ubuntu. After the name of the project, there was WSL Ubuntu. And even at the bottom. So now, so you can open as we've done using Visual Code. If you don't want to open using Visual Code, you can also open using Nano or Vim in the terminal, and the steps are again here. The steps for doing that again here. You open your code, and then after it opens, you proceed to edit. So you can also open it using GUI text editor on Windows. And again, these are the steps that you may want to use if that is the program you have, and if that is the one you want to use to edit your program. Now, so after that, I had already explained this code. This is the first one you get when you write code dot code dash code space then dot. If you had not written anything in it, this is the default that you see. We saw this default where I was saying that it checks whether X is not equal to Y. So this is the one we saw. Then we ran by Nago test. I had already mentioned the issue of the private and the public inputs. And I'd said, in this case, X is, since there was no word pub before field when referring to X, and then it's taken as private by default. But if you write the word pub, then it means it becomes public. Now, I'd already explained that first code ensures that X is not equal to Y. So this one I'd already explained. So if you make X1 to be X and Y to be that, then if you run Nago test, it will not compile because X will not be equal to X at that time will not be equal to Y because they'll be equal. Now, if you wanted to open another code, another program, again, I had already said you would still go to a WSL and then use the same procedure of opening a program. And that is how you then do it. This is the procedure. I've just again repeated the procedure here. Suppose you want to open your program that is now called addition project. You would say Nago new addition project, but that must be inside the Rust programs. Begin by CD, Rust programs. Then Nago new addition project. Then after you've created it, now go into it, navigate into this new project by CD addition project. And then after you've navigated there, now write code space dot. That opens for you the Visual Code, which you then proceed to and go to main.nr, delete whatever is there, and put your code that you want. So you are editing the existing main.nr. That is the one you edit. Replace it by what you want. So you may replace it by this, and this is the example I had already explained, where we are doing summation of x and y, and you can see the output is public, and this time the input and both the inputs are x and y are private. You may want to make them public, or you may want to make one of them public, but now after that there must be test. We're testing the main function, and let if x is 3 and y is 5, then the sum is 8. That is what you're giving as your test. Now, so I'd already explained this, what that code is doing. The explanation is here. The explanation is here. I'm just saying which one is private, which one is public. And I'm saying that the output must always be marked public. This point is here, just to repeat it so that whenever you're writing your program, you're writing it properly. Now, this tests defines the test case that calls the main function, expecting the result to be 8. So you use an assert statement to verify the correctness. So the assert statement is just used to verify the correctness. If the assertion passes, that confirms that the main computes correctly. But if it fails, then it means the main does not compute correctly. Now, so this is another code. I already explained it again when we were in the visual code. So whatever I was explaining, we already have. These are the notes so that you can look at it later and create your programs properly. This one I had not explained, but it's another code. It's another code you create it. Now this time I have A, B, C, D as and F as fields. A, B, C, D are the fields here. And then I have part 1. You see what I wanted was, let me just see what I wanted. Okay, just looking at the code, just looking at, let me see where am I sharing. Okay, so looking at this, part one I can see is B times A. Part 2 I can see is C times D times F. That's part 2. And I can see that Z is A plus part 1, then plus part 2. And then assert that Z is 76. So the prover claims to know what Z is, but Z is given by A plus B multiplied by A plus B multiplied by A plus C multiplied by D multiplied by F. So the prover claims to know what Z is. So the verifier wants to know whether this prover knows what Z is. So this guy is supposed to give us Z. And whenever he gives us Z, he must give us A, must give us B, must give us C, D, and F. So since this is what we want to write, this is a bit complicated. So what you do, you must have this part computed as part 1, this part computed as part 2, and then after that, what you want to prove was Z is A multiplied by part 1, no, plus part 1, then plus part 2. So that's what you now write. But what you had on your mind is this. So this is what we now write. That's what it is. We are doing this because remember, when you're doing your rank 1 constraint system, we said that there must be only one multiplication. There must be only one multiplication. You can see the multiplications we have here, several, and so because of that, but there was no limit on the number of additions. There was no limit on how many additions you should have. So while there are several multiplications, we make them like, see the three. So just these are two. So these are three. So just make them one. Make it one. But now we can make this one. We just call it part 2, and we have a value here. We have a one value here which we will add, and then again this one, call it part 1, and we have one value there which we will then add. So we have no limit for what we are adding. Now it knows it will do part 1 as this product and part 2 as this product. And then after getting this product, it just comes the final one. The final one must have what all these parts combined. So this is just to ensure that it's in rank 1 constraint system, which we had earlier on looked at. So that is what it ensures. Now, so today I just want to take you through the process of creating a project, writing a project, storing that project, and so on, so that next time when we meet, we'll look at now how to write zero knowledge proofs, where we'll now want to verify the proof, prove the proof, and so on. That is what we'll be doing. And maybe before that, we'll need to install Nago using the Noir app, because the current Noir that we installed does not have the part for Nago prove and Nago verify. But there's a way you can go around it, although it does not have those commands. There's a way you can go around it. So I'll show you how to go around it without Nago prove and Nago verify. But then after that, we'll need to install another Nago, uninstall the one that we have, and install the one that the latest, that will now allow us to use those commands. So that is where we then stop. And if you had not looked at our video where we began looking at Noir, especially the installation part, you can go look at it, install, so that we progress together. Thank you.